I hope everybody else enjoyed that last panel as much as I did. 非常感谢你们. We agreed we're going to do, I live in Hong Kong and my wife is Chinese and I speak bad Chinese, so we agreed we're going to do one of these things in Chinese next time. I speak Cantonese and Mandarin both poorly. But no, jokes aside, look, Bitcoin is where it all started. I've been a Bitcoiner for a long time, so I'm excited that you guys are pushing the envelope on Bitcoin and bringing DeFi to Bitcoin. For slides, okay, perfect, yes. And the timer here will turn on as well. I want to keep an eye on time. Is that possible? Yeah? I recognize I'm the last speaker between you guys and happy hour, so I won't go over 15 minutes. Oh, there's one more after. Okay, perfect. Okay, but yeah, I'll keep it brief. Excellent. All right. So, yes, I'm Lane. I am head of research at Near Foundation. Really excited to be here. Excited to connect with the Sensei Node community and also just the crypto community in Latin America. I've been in the industry. Actually, let me just go to my slide here. I'm showing my age here. I've been doing IT stuff for not quite 30 years. I've been in the crypto industry for about 8 going on 9 years now. I was an Ethereum core developer for a while. I worked on a project called Space Mesh, and I joined Near last year. And so I've been to Latin America a few times over the years during this journey with Ethereum, and then for some independent research stuff, including in Argentina and El Salvador and Colombia and a few other places. And yeah, just the energy here is incredible. I think that especially in Argentina, people here really deeply understand why crypto matters, why Bitcoin matters. So it's good to be back. Cool. So yeah, just some boring legal disclaimers. I am here to share a little bit about what we're working on at Near AI, and just kind of Near protocol, Near Foundation more generally. I'll talk a little bit about why privacy and private AI tools matter so much, about this vision we have for a user-owned AI. Again, I have a lot of slides and I'm not gonna get through all of them, so we'll see how far we get. But also, if there's time, I'll introduce you guys to some of the AI products that we have as well and give you a sneak peek of what's coming next. So not everybody knows this actually, but Near was actually founded way back in 2017 as an AI project. And our 2 co-founders, Ilya and Alex, are actually AI pioneers. They were early AI researchers at Microsoft and Google. Alex also spent time at OpenAI. And Ilya is particularly well known for being the co-author on the Attention is All You Need paper in 2018, I think, at Google. It was published in 2018. And that was actually the paper that kicked off the transformer revolution, right? So that's the T in GPT. And then the story here is that they actually launched Near Protocol shortly thereafter in 2018 because they were trying to do things that blockchains at the time couldn't do. And they kind of realized that both for payments as well as for AI, we needed better kind of blockchain protocols. So the Near blockchain is actually kind of like a spin-off of the original Near AI, and we're kind of now getting back into the AI game. So yeah, the Near blockchain ecosystem started in 2018. The mainnet went live in 2020. We have a number of products, right? There's a very exciting product called Chain Abstraction, which many of you folks may know under the name Near Intense. Chain Abstraction is the underlying technology that allows you to orchestrate and control accounts across many different chains and protocols natively using a single set of Near keys or Near credentials. We have a product called Near Intense, which operates as kind of this native trustless cross-chain interoperability protocol based on intents for people who are familiar with the idea of intents as opposed to instructions, right? You kind of say, I want to achieve this outcome, I want to swap this asset for that asset, and then you have a network, a decentralized network of solvers, right, that solve that for you and can move things across protocols and across chains. And the AI stuff, again, we started with AI, but we've kind of pivoted back to AI. So the current AI work started just about a year and a half ago. For anyone who's not familiar with Near, I mean, just re-emphasizing the point, it's got several kind of products and components to it. First and foremost, it is a sharded blockchain. We have, I think, 9 shards that are live on mainnet right now. We're one of the only production sharded blockchains. And we're actually very close to achieving 1 million transactions per second. We had some tests recently. I know it's a bit of a vanity metric and everyone throws it out there. But actually with shards, it's like very much within reach and very achievable, right? Because we just kind of need to spin up a few more shards and we'll actually be able to achieve this transaction throughput. And I think this is very important for AI use cases, right? Because agents will transact orders of magnitude more transactions, higher throughput than humans. We have the core protocol, we have the TEE, trusted execution environment stuff, which I'll speak about in a moment. Chain abstraction I mentioned, near intents I mentioned. House of Stake is the governance project. So actually, these numbers are pretty out of date, and I was trying to update them today, but as I'm sure everyone here knows, nothing was working. So Dune was down today, so I couldn't actually pull in the latest numbers. Yeah, Near's been live for a while. We have a lot of transaction throughput. Near intents in particular, I think this all-time volume figure is actually closer to not quite 3 billion, maybe 2.5 billion, something like that. It's really growing very rapidly. So it's a product that's found really awesome product market fit, which is exciting. So yeah, so we have all this infrastructure in place. That's great, but like, what now? What's next? What are we using it for? What does this enable? I think the way we look at the world is we just see that AI is coming. AI is, famously, Andreessen said that software is eating the world. Now I think AI is eating software. AGI is maybe around the corner, depending on how you feel about this. But in particular, it's kind of, if you extrapolate based on the state of the world today and the degree to which big companies like the obvious ones, Google, OpenAI, Anthropic, et cetera, kind of control the keys to the kingdom, the models, the inference engines, the data, things like that, it's a pretty scary dystopian future, right? If we can't kind of turn things around and take some kind of community control and ownership here, not to mention having privacy and confidentiality. I think another way to frame it is to think about the way that we as humans just kind of interact with the internet today, right? We have this set of technologies, things like web browsers, search engines, advertising business model, things like that. That is about to be turned upside down by AI. And it's starting, right? It's underway right now. Ilya, our co-founder, likes to call AI the final interface. And I like that a lot, right? Because we have kind of apps and services and APIs and things like this today. The Web 2 world, obviously we have stuff in Web 3 that kind of works, but it's not ideal, it's not great, and I think a conversational mode of interaction is much more natural, maybe not for everything, but for many, many, many kinds of products and services. Like, just one random example, I hate shopping, but like I have no choice but to use websites like Amazon. I think Amazon is like the shittiest website on earth. It's 90% sponsored links and ads and garbage. The AI tools are not great at shopping yet, but they're getting better. They're getting better actually, and I think it's just kind of around the corner when we have this kind of new stack of technologies that's more responsive to our needs. So what we're trying to build at Near is the middle layer here, right? Just kind of all the infrastructure that's needed to power this user-owned AI future. The way things work today, right? It's kind of like this. You're kind of like serving your data, to these centralized apps and services, and they, including AI, right? And they kind of provide services to you or not, right? Depending on how much you're willing to pay, how long you're willing to wait. This is not great, right? We're giving our private data to, obviously to Sam Altman and OpenAI and all these new AI projects. I guess we've been giving our data to Google and other companies like that for a long time. I think everyone's aware of this. It's not an ideal situation. It's pretty scary when you think about how powerful AI is and what it knows about us and will be able to predict about us. But this is how things should look, right? This is kind of a better version of the future where you don't need to give your data to anyone, right? You keep your data in a sovereign fashion, and the way you do that is using things like I'm dyslexic, trusted execution environments. I'll walk you through how that works in a moment. And the application just establishes a secure link, right? It doesn't exfiltrate or steal any of your data, right? You have complete control over your data. Everything's end-to-end encrypted. You saw this already, right? So yeah, this is moving to the new kind of technology stack. The key thing is that we need privacy at the foundation of AI, of everything, right? In order for AI to be useful, it needs context. That I was reading and thinking, talking to some people recently, AI technology is really good, actually. It's really powerful already. The models are very, very powerful. The inference tools are very powerful. The biggest issue today is not the raw horsepower, the raw power of the AI or the number of parameters in the model or whatever. It's actually context, right? This is what I struggle with. The more context I can give AI tools, the better the answers I get. And the context windows are growing, but they're still limited. There's issues with memory, right? How does AI remember the conversations I had with it? That's a version of context. There's shared context, right? I want to share the context with my team. And so the more data it has access to, the better it is, but that leads to privacy issues, obviously. And so, yeah, in order to deliver on the better version of the future, I think we need to earn the trust of users by giving them private AI tools. Okay, this screen is updating, but that one's not. Let's see. This screen is not updating. This screen is moving. Is it possible to? That's very odd. Okay, it's just one slide. Sorry, I don't know what's going on. Okay, I'll look back here. So, right, there are existing approaches out there to doing kind of some version of secure AI, trust-based systems, on-premises, cloud confidential compute, right? So trust-based systems, sure, you can keep things kind of private, but then, you know, you're still sharing your data effectively with someone else. And they can't, it's a trust me bro kind of model, right? On-premise deployment, this is something a lot of big companies are asking for. And it helps, right? It's better to keep your servers in-house than to give all your data to Anthropic or OpenAI. However, it's very expensive, right? It requires, you know, having specialized hardware. It's very complex to maintain. And then you'll notice, actually, Amazon and Google have both, very recently, within the past few days, launched confidential computing solutions for AI stuff, which is cool. I like that it's there. But they're limited in what they can provide. And again, it's still a trust me bro model, right? They have no way to kind of cryptographically assert or prove to you that your data is secure. They're kind of trusting them. And so the near solution to this is something we call DCML, Decentralized Confidential Machine Learning. It's a bit of a mouthful, but it's just a single name for kind of all the infrastructure that we're delivering to kind of solve these problems. And if you search for decentralized confidential machine learning on Google, I'm sorry, I didn't include a QR code here, but there's a paper that was published a few months ago that kind of walks through what that looks like. So yeah, so we have a number of kind of approaches out there, competing approaches to doing confidential machine learning or confidential AI, and each one is kind of limited, right? So ZKML, using zero knowledge proofs, very, very large overhead. It's very, very slow, and you get verifiability, but not confidentiality. Yeah, there's consensus engines, which, as we all know, consensus is very slow and expensive. Again, not confidential. We have FHE, fully homomorphic encryption, super cool technology. Yeah, it's just, again, it slows things down too much. You can do things locally, but you're very limited in the size of the models you can run locally. And then we arrive at TEEs, trusted execution environments, right? That's the technology we've landed on. It's not absolutely perfect. It's not bulletproof, right? There are a few kind of potential attacks we've seen. But used, the way we're using it, the overhead is very minimal, right? In our own kind of benchmarking, we're seeing as little as 1% and at a maximum about 5% overhead. Compare that to 100x, 1000x, 10,000x for other kind of solutions. So it's a very practical solution that's here today. Sorry, there is the QR code. Okay, so if you want to read more about DCML, the paper, check this out. I'm going to move a little bit faster. I don't have a whole lot of time left, and I at least want to get through just kind of the high-level architecture. So yeah, so these trusted execution environments, also known as secure enclaves, have been around in CPUs for a long time. So for example, on your phone, if you scan your face or your thumbprint, right, that happens inside a TEE. However, they very recently were rolled out on the latest generation of GPUs as of last year. I think the NVIDIA Broadwell class of GPUs. And the GPU TEE can talk to the CPU TEE, which means it can really kind of set up this thing we call a CVM or a confidential VM and keep all of your data secure. And for all of the computation that happens, you get a cryptographic proof that it happens securely, verifiably, faithfully. So here's just a high-level schematic of what it looks like, right? We have the code itself, and in near, the code is always reproducible build, right? So you can build it yourself independently. You can audit the code, look at the kind of hash, and ensure that it's the same thing. And that's attested to on chain as well. So we have a registry there. And then you spin up the CVM, this confidential VM, and inside of it, it has the CPU side and the GPU side, right? And they talk to each other securely, and you get an attestation for both, for the CPU and the GPU work. It can be, again, I'm going to move pretty quickly. Those images, which, as I said, exist on chain, can actually be upgraded as well. This is one of the key things the blockchain gives us. And then a really cool thing is the models themselves, right? So one thing we want to do is enable people, model creators, people who are building models, training them, fine-tuning them, et cetera, to actually be able to monetize that, which means that they can open source those models, right? But the model itself remains encrypted and is just kind of run inside this secure environment. And then, this is another sub-protocol, right? There's kind of a number of pieces of the puzzle to get this working. We have another protocol that we've developed here called proof of response. Again, there's a paper here you can read on it. But this is how we decentralize it, right? We want to make sure that a variety of different node operators can participate. So this is particularly interesting to any of you guys out there, Sensei Node, Metapool, et cetera, you folks who are providing that decentralized infrastructure. This is how you can attest to the protocol that you're going to deliver responses quickly to queries, and that you are effectively slashed or punished if those don't come through on time. Yeah, so this is a high-level overview of what the protocol looks like. We have the on-chain registry and payment system, which I mentioned, right? That's all handled on-chain. The user runs agents and inference inside the CVMs, and some have GPUs, some do not. And the proof of response protocol provides the transport layer. And this is how the monetization works. Again, so for those model developers, right? Again, there's kind of too much detail here to get into, but effectively the model developer has also cryptographic proofs that inferences run against their models, and they're able to kind of monetize that using this set of protocols. I mentioned benchmarks, right? So you can see on the top here in our benchmark work that the throughput is, again, just kind of like single-digit % slower than what you get with the non-TE, the native version of the models. And the kind of time factor is a tiny, tiny, tiny bit higher. So it takes slightly longer, just slightly longer to get kind of the first responses. We have a proof of concept of this you can play with today. So if you go to chat.near.ai on the web, we have a private chat which looks and feels a lot like a ChatGPT or a Claude. But this is what the verification looks like. I think it's pretty cool. So there's actually a little, I don't know if you can see it on this image, but there's a little lock icon, right? A lot like the early days of HTTPS. You have a little lock icon to show you that the transport layer is secure. You click on that and you can actually see these attestations, these cryptographic proofs from Intel, from NVIDIA, from the CPU code, the GPU code. And there's instructions there where you can actually go verify them directly with NVIDIA and with Intel to prove that everything, again, is end-to-end encrypted, everything's secure and confidential. So, right, summary of what the workflow looks like. Everything runs inside these hardware-isolated environments, right? Everything is signed, et cetera. You can verify things independently. I guess I'll kind of end here because I'm basically out of time. But right, where do we go from here? Users basically just retain self-sovereignty over their data, right? We can continue to use the AI tools that we love, things that we use today. I think the vision here from the kind of infrastructure perspective is that Near AI will provide all of the same sort of APIs, all the same tools that you get from an OpenAI, from a Google or Gemini, from an Anthropic, et cetera, but with all these additional guarantees and with the additional benefit of running on decentralized infrastructure, which enables this open innovation ecosystem, which really should lead to a flourishing, a kind of Cambrian explosion of new app developers, of new models, right? Because again, they'll be able to monetize things in a way that they're not able to do that today. Cool, yeah, let me end there. I don't want to stand between you guys and happy hour and panels. I'll be around if you have any questions, if you're interested in learning more about Near AI, about how to get started with it. Thank you guys for your time. It's great to be here. Enjoy the rest of DevConnect. Thank you.